Have you ever considered how the very act of gathering information, especially in healthcare, might subtly influence the conclusions we draw? It is a fascinating challenge that underlies much of the powerful data analysis shaping our world today. Data collection causes measurement bias by introducing systematic errors into the information we gather, meaning that our measurements consistently deviate from the true value in a particular direction. This happens when the methods used to collect data are flawed, inconsistent, or applied unevenly across different groups. The core mechanism behind measurement bias stems from a systematic issue, not just random chance. For instance, if a blood pressure monitor is consistently miscalibrated, it will always report readings 5 points higher than they actually are. That is a systematic error, but it goes deeper than just instruments. Consider observer bias, where a data collector's expectations or beliefs subtly influence how they record information, perhaps seeing symptoms more readily in one group of patients than another. Participant bias is also common, such as when individuals provide answers they think are socially desirable rather than entirely truthful, or when their memory recall for past events is inaccurate. Furthermore, if our sampling methods lead us to collect data from a group that is not truly representative of the broader population, any measurements taken from that representative sample will inherently be biased when generalized. These systematic errors, if present in the data used to train artificial intelligence models for medical diagnosis, mean the artificial intelligence will learn and perpetuate these inaccuracies. This can lead to significant disparities, potentially causing an artificial intelligence system to underdiagnose conditions in certain populations while overdiagnosing them in others. To mitigate measurement bias, we need to be proactive and thoughtful in our data collection strategies. This involves implementing highly standardized protocols across all data collectors, ensuring everyone follows the exact same steps every single time. Rigorous training for data collectors can minimize observer bias, teaching them to remain objective and consistent. Calibrating all measurement instruments regularly and precisely is absolutely crucial. Also, designing studies with diverse and representative participant groups helps ensure that the data truly reflects the population it aims to describe, reducing sampling bias. Piloting data collection methods with a small group first allows us to catch and correct potential issues before a large-scale rollout. A particularly insidious form of measurement bias is known as differential misclassification. This occurs when the errors in measurement are not just systematic but also vary across different subgroups within your population. For example, if a diagnostic test consistently performs less accurately for patients of a specific ethnicity or socioeconomic background than for others, that is differential misclassification. This type of bias can silently exacerbate health inequities, as the very tools intended to help may be systematically failing particular communities, leading to delayed or incorrect diagnoses and treatments where they are needed most. Recognizing this nuanced layer of bias is vital for true fairness. Ultimately, understanding how data collection can introduce measurement bias is not merely an academic exercise. It is a critical step towards building more robust, equitable, and trustworthy artificial intelligence systems in healthcare. By meticulously designing our data collection processes to minimize these systematic errors, we empower artificial intelligence to deliver more accurate diagnoses and personalized treatments for everyone, fostering greater trust in technological advancements and promoting better patient outcomes across the board.